Okay, hi everyone. I think I really bungled this trying to do two streams right after another thing because I entered the wrong stream earlier. Anyway, in this stream, we're going to talk about keyless authentication for Azure OpenAI to show you how you can authenticate to your OpenAI without keys. So hello, John, and thank you for those of you who jumped out of the last stream and jumped into this stream. I think in the future, I will just schedule one stream because it is way less confusing. Okay, so the repo I'm going to start off with here is appropriately named Azure OpenAI Keyless. And this is a repo that sole purpose in life is to help you to get started with keyless Azure OpenAI authentication. So let me open it up here. Okay, so what do we do here? All right, so as always, this uses my favorite CLI, the AZD CLI, for provisioning Azure OpenAI. You can also use Azure CLI. You can use Azure Portal, but this takes care of setting up the right roles for you. So then we're going to provision the OpenAI account. And I've already provisioned it. So it's just doing a reprovision now, and it might decide to even just skip it if nothing has changed. But I'll show you what's in our in our main.bicep here. So this creates a resource group for the OpenAI instance, and then it creates the actual OpenAI with a deployment. So with Azure OpenAI, you have to do a deployment. You don't simply just access a model that exists. You have to say, okay, I want a GPT-3.5 Turbo. I want a GPT-4 32K. I want a ADA 002. You have to be specific about what you want. And you have to give it, you say like, what's the model name? What's the model version, right? Is it 0613? These are all like time date stamps, and then, yeah, so you specify all that. You give it a deployment name because you can actually have multiple GPT-3.5s, right? You can have one named chat, one named chat 2. And this can be, it makes things kind of confusing because it's different from OpenAI.com, because OpenAI.com, you don't have multiple deployments. You just can use a model. But it does, in theory, make it easier for companies, teams, because you can say, all right, well, this deployment has this name and has this capacity. So you make sure you don't go over that capacity. And then this, we have this other deployment with such and such capacity. So that's something to know if you're moving from OpenAI.com to Azure OpenAI is deployments. You will always have to specify your deployment name whenever you're trying to use your OpenAI account. And then the next thing that this bicep does is that it creates the permissions for accessing this OpenAI. And this is how I'm going to be able to access it locally. So you can see here is that I say, okay, I am creating a role. This is a, what's called an RBAC role, resource-based access control, right? So if you're looking for this on Azure, like you search for Azure, Azure RBAC role assignment, and you'll find some good documents about it. And we have all these like preset roles that you can use, and we can look it up this one, right? So if we look up this one, we'll get to the Azure built-in roles website, which I visit quite frequently to figure out what roles I need. And we can Control F for this, and we see that it is the cognitive services OpenAI user, and it has read access to view files, models, deployments, and the ability to create completion and embedding calls. So it's good. That is what we need access for. If we were doing something else like fine tuning, then we might need a different role like the one above here. So there we go. We do the role, and then we have to set it to our principal ID. So once again, this is my own user's principal ID. Now I'm using AZD to pass this in. So in my main.parameters.json, I say set the principal ID equal to this environment variable that AZD always has, which is Azure _principal _ID, and that sets it in. If you were doing this a different way and you didn't know your principal ID, you can still find it out. So I did a blog post about keyless authentication Azure OpenAI, where I talk a lot about this. So definitely check out this blog post because this is basically a video version of the blog post. All right, because you could do this with the Azure CLI as well. The important thing is to know, what is your principal ID. So let's see, principal ID. Okay, so here you could run a command to get that. So I gave a little command that you could run, right? So let's do a new tab. So this is using the Azure CLI. Okay, so it says this is my principal ID here, right? And so once you know that, then you can use it with the Azure CLI to create a role. So this is if you wanted to do this with Azure CLI, you could just run this command. So some of you might find it easier to do that. The important thing is we need to explicitly give access for our our user's ID to be able to access OpenAI, because otherwise you don't default to having access, which is good, right? That you don't default to just being able to, access something. We have to always explicitly give access when we're not using keys. We always have to explicitly give access. Okay, so yeah, so we have a good question. If this is passwordless, then how would it work? Okay, so let's see how it actually works, right? So we made, we provisioned this, and then the next step is I'm just going to copy the AZD outputs into a .env. So we can see here that I've got my GPT deployment, my GPT model, and my OpenAI service. These are generally the things that matter for when we're trying to actually use the OpenAI SDK. So now let's go to our example file here. Okay, so this, this example here, we are using the Azure.identity SDK. This is in Python. You could do something similar in other languages, right? So we're using Azure.identity SDK, and we use that to get a token provider for our default credential. So I just talked about in our last stream is that the default credential tries to figure out how you're logged in, whether it's via the Azure CLI or AZD CLI or whatever. It's just going to go through all these possible ways you might be logged in until it finally finds, something that says how you're logged in. So we're going to, use that credential to get a token provider for this scope. So this is the scope, and this is the scope for OpenAI. So if we're trying to get a token provider for OpenAI, we must specify this scope. If we get that wrong, we will be sad. So we get this token provider. So this is not the token itself. This is a token provider. A token provider is a function that knows how to get tokens. And the reason in this case that we specify a token provider is that allows the SDK to dynamically get more tokens. And that's useful because tokens can expire. They have expiration dates, right? But if you give it a token provider, it can try to dynamically get new tokens as long as you're still logged in. So we give it a token provider. So here, I say I use from the OpenAI SDK, the Azure OpenAI class. I specify API version, the Azure endpoint, and then my Azure AD token provider. So this is all I need to specify for the constructor for OpenAI. And then when I'm doing a chat completion request, I specify the name of the deployment as the model. This is probably the most confusing aspect of using Azure OpenAI, is that you pass in the deployment name as the model. And they did this so they could avoid having to add an additional parameter to this generic function. They didn't want to have to add deployment just for Azure, but it's super confusing because you really have to know that you got to pass in that deployment there. So yeah, so we needed to know our service name, our deployment name, and that's all we had to know in order to do that. So I can run this code here, Python example.py. And what's it going to do? It's going to write a poem about tuna, which is what I always make it do. And that worked. So the nice thing about here is that we didn't have to pass in a key. And so, the question earlier, like, how does it actually work? So this is behind the scenes, this is all using OAuth 2. And the idea here is that I did the work to authenticate here, right? Like, usually I break this out into its own line. So let me break this out, right? And I could, let me log out to show. So this is the point where I'm doing the work of authenticating, right? So if I have to run azd auth login, and then it opened it up in the browser you can't see. Let me open it up in the browser you can see over here. Okay, and so this is a point. So at this point, my provider, my identity provider, Microsoft, can decide to give me an MFA, to have me use my phone app. Hopefully it won't, because I'm streaming with my phone. But that's up to the provider, right? Luckily it's happy and is just letting me do it without going through an MFA step this morning. But later on today, it might have me do the MFA. So this thing here that's the point where I'm doing any sort of whatever authentication dance my identity provider wants me to do, that Microsoft wants me to do, I do it at this point. Then in the actual Python code, we're just doing default Azure credential, and it's finding that existing, authenticated user in the environment and using that and getting a token provider for that. So you can imagine that a token, when the Azure OpenAI SDK, when you do a call like this, it's actually going to ask the token provider for a token. Like, hey, token provider, give me a token. And so that's going to get a fresh token, and that's going to pass that it's actually going to like set a header, like authorization bearer, token. And that's going to be what came back from the token provider. So in a way, we are passing in something like a password or a key, but the significant thing here is that these tokens are short-lived, and they have expirations, and we can easily stop them from working. Like, we can revoke them, they can expire. We don't have to store them in plain text, right? Because they're fetched dynamically. So generally, using a token based form of authentication is going to be more secure than using a key based system, because keys, they get passed around, they get checked into source code. There can be a pain to rotate. This one has like auto rotation built in, right? So when you can, it's always nice to be able to use a token provider instead of passing in a static API key. All right. Yeah, it's a good question. I've been actually reading OAuth 2 books to try and really wrap my head around how all this works, because OAuth 2 is pretty complex. So I am still learning as well. Okay, so the next thing we want to do is actually, authenticate in an app to use Azure OpenAI. So let me find an app that does that. We have lots of apps that do that. Okay, so let me just check out main, get pool. So all of my apps have it all set up. So if you're looking for any apps that have it, you can just look at any of these. Azure Search OpenAI demo, this Court app, this Fast API app, they all have keyless authentication set up. So we can look at the big one. This is the one I show a lot because it's what I spend a lot of my time on. But this one is setting up an app on app service, and this uses keyless authentication for the app service app to communicate with OpenAI, so that we don't have to store any key in our app service environment variables. So how, let's just see what this looks like in the, first in the SDK code. So let me go here and look for our OpenAI class. So here we can see that, if the host starts with Azure, then we get the bearer token provider just like before. And then we pass that in to the Azure OpenAI class. In this case, we're using the async class, but the parameters are the same there. So the reason this works is because we've set the role. So let's go ahead and look at the bicep, and let me look for system identities. Okay. So we have set a role here for the actual backend. So when we create this role, so before, remember when we created the role, and I can show it down here because we have the user roles. Oh no, the user roles are up, 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 up. So many user roles now. Okay. All right. So these are the user roles, right? So this is the user role that I showed before where we created it for ourselves so we could access OpenAI locally. So this is set to our own principal ID, and this is a user type. And this is the OpenAI user role. So then we also set the same role for the app. So we say, okay, here is the principal ID of the app. And this is the role definition ID. So that's the same one as before, the OpenAI, user role, whatever. In this case, the principal type is service principal. So we're we're telling it that, hey, this is not like a user, this is a service principal. So it's a slightly, different form of granting a role. So that's it. So we basically, like, if we could compare these side by side, right? And this is generally how you set up keyless authentication for most Azure services. So once you understand this for OpenAI, you should be able to do it for other ones as well. Is that you create you create the service, you give it an identity, a managed identity, and then you figure out what's the right RBAC role, right? So going back to our favorite website, the built-in roles website. So figure out like, okay, this is the role. So you give that role to to yourself, and you give that role to the backend application as well. And yeah, you can see that we do this for everything, for storage. And I mean, sometimes you're gonna have different roles locally versus deployed. Like the only reason we need the local roles is because we do use local development with this, and we want access to OpenAI locally. You don't always need local access to your Azure stuff. Like when I'm doing stuff with Postgres, when I'm developing locally, I just use a local Postgres because it's very much like my deployed Postgres. So there I wouldn't need a local role most of the time. So you do want to think carefully about whether you actually truly need, do you actually need access to that Azure service locally? For OpenAI, you almost always do want it, but for something else, you may not actually need it. So the roles are not always going to be exactly the same for your local user versus your deployed application, but they might be similar depending on what sort of local development you have to do. So this one is doing what's called system identity, right? And that's, we set that up via, let's see, app service.bicep. Okay, so we just said managed identity true, and that just turns on managed identity for the app service app. The other thing you can do in Azure is called a user assigned identity. And this is pretty confusing. Let me see if I can open it up. Let's see, show an example. Okay. So, let's look at one that has the system identity. Okay, we go here. This is an app service app. We go to identity. And when you click on identity, you see two tabs. You see system assigned and you see user assigned. So we have system assigned on, and that's the actual principal ID. Like this principal ID is the one that got assigned the role. That's what got passed into that role definition, is this system ID. So a system assigned identity is an identity that is associated with that app. So if that app, if you pull that app down, that system assigned identity ceases to exist. That identity only exists as long as that app is, exists, in your Azure account. A user assigned identity is one that you create independently outside of the app, and then you can tell the app like, hey, you can use this user assigned identity. So there's more flexibility in user assigned identities because they have a lifespan, outside of the app. So they're really helpful if you're trying to use the same user assigned identity across multiple resources. So we almost always use user assigned when we're doing container apps because we use the same user assigned identity for the container registry as a container app, so that we can deploy a container to the registry and then also set that as the image for the app. So let me find let's see, fast APIs. Yeah, okay. So this one should be a container app. So we'll go open the container app and then look at the application. No, look at settings, identity. Okay. So here you can see system assigned is actually off. But if I go to user assigned, fingers crossed. Yeah. So if we go to user assigned, we do see that there is a user assigned identity for this one. And that is actually what we use for the container app. So that code looks a little bit different. Let me open up. I think it'll be this one. I'll just show it in GitHub. So if we go and look at our main.bicep, this one is also setting a role, but this time the principal ID is of that user assigned identity. Okay, so this principal ID is in fact a user assigned identity. And it's just that we make it a little bit different. So you can actually see that it is a separate bicep resource. So this is a actual separate resource that we create. And then we tell the container app like, hey, associate yourself with this identity. And it gives it you can give it actually a whole list of identities, right? But here you can clearly see that this is a separate Azure resource that gets created outside of another resource. So that's really the difference between the system identity and the user side identity, is that just the system identity, it's tied to the resource, it's part of it, it's there if the resource is there and not if it's gone. And user assigned identity, we can create it before, and it'll live before and after. And now the thing that's significant is that with a user assigned identity, you could have multiple user assigned identities, right? So you have to know what user assigned identity you are actually trying to authenticate as, which does complicate the credential a little bit. So if we look at the code for this and go into, let's see, maybe here. Yeah. Okay. So what you can see is that I actually store the ID of that principal in the environment on the deployed app. And if it is there, I specify that client ID. And I even specifically use the managed identity credential class, because at that point, I know I'm using a managed identity credential. And so I just pass it in there. There is actually a way to pass it into default Azure credential too. But I just thought this was cleaner. So this is the complexity to using a user assigned identity, is that because you could have multiple, there's not just a single one that's always associated with that container app. You have to tell it like, hey, this is the ID I'm trying to use, right? So you'd actually have to tell it like this ID here and store that in the environment variable. So we should be able to see that actually if we go to our containers and we look at our environment variables. And you can see actually it's the not the name of it, it's the ID of it. So this is what we would have to pass in here in order to make sure it knew how to authenticate as the correct identity. Okay. So that's I think most of it. And I also updated. I have this other repo, Python OpenAI demos, and it uses is compatible with keyless auth for all the examples, and it has LangChain as well as Llama Index, which I just added today because they just added a keyless support like 2 days ago. So if you're looking for more examples, I'll push the Llama Index one right after. But basically, with LangChain, right, we can do something similar where we specify the token provider. So I can run the LangChain example here. And, once you can see, we are not passing in a key. Oh, wait, I'm on a Llama mode right now. Let me go back to, I was playing around with Llama because I saw somebody posted about Llama 3. Yeah, I also would like to try Llama 3, but I haven't had a chance yet. So let me go back to this one and see if it is working right now. Okay, so that's the response from Azure. And then let's try Llama Index, and that has a very similar constructor. And we'll run this. But so generally that's what we're hoping, is that all of these libraries that wrap Azure OpenAI, we're hoping to see them all add support for keyless authentication, and helping them add support via pull requests if that's what we need to do, so that anybody who wants to use keyless authentication can do so. So excited to see that Llama Index has it now. and looking forward to seeing more packages support it, because it's really nice to not have any keys in my .env, because now I can show you my .env. All right. That is what I wanted to show about keyless. Once again, check the blog post because it talks pretty much about everything I showed here. So it is a good recap or refresher for this. And I recommend that you now head over to the VS Code channel for the Python polls, because Marlene is going to be talking with Dawn about LangChain, which we just saw. So I am looking forward to learning more. All right. Thanks, everyone.